Our study of complex and imaginary numbers begins with two key definitions. First off, we all know that we can't take the square root of a negative 1 in the real number system, but in the imaginary number system, this is the definition of I. And a partner definition is I squared is equal to negative 1. Normally, whenever you square a real number, the answer must be positive, but the square of I becomes negative 1. We can use these definitions to simplify these following problems. When we have the square root of negative 25, we can think of this as the square root of negative 1 times 25, and the square root of that negative 1 gives us an I. So this expression is equal to 5i. Likewise, this next problem is going to be a negative 1 out front times the answer we just got, which is going to be negative 5i. However, I want to remind you that tell you that this cannot simplify any further. An I is not negative, and therefore the I and the negative do not cancel each other out. I is not negative because it's the square root of a negative, which is a totally different thing. In this next problem, we're going to simplify each of these radicals separately. We're going to have 4i plus 6i, which simply enough is going to add together to be 10i. Here is the only property of real numbers that we've got to change a little bit. You may not multiply the radicands together and get the square root of 18 because we're dealing with imaginary numbers. What you want to do instead is pull out the i's first. Write this as I root 3 times I root 6, and then multiply together to get I squared root 18, which turns this into a negative 3 root 2 rather than a positive 3 root 2. I'd like to say that the order of operations is changed now. It's no longer please excuse my dear Aunt Sally with P for parentheses first. I'd like to say I please excuse my dear Aunt Sally. Pull out the negatives from inside radicals to i's before you do the other order of operations. If you do that, then you're going to be okay. Now, complex numbers are of the form a plus bi. It's what you get when you combine a real number and an imaginary number together. The a is considered to be the real part, and the bi is considered to be the imaginary part. It's kind of like a molecule where you're joined together two different elements to form a molecule. We're doing the same thing, adding a real and imaginary part together. When it comes to adding and subtracting complex numbers, basically you're combining like terms. Combine the real numbers and the imaginary parts separately. This is going to give us, for this problem, 4 plus 3i. Now, never write this as 3i plus 4. It's always the real part first, the imaginary part afterwards. When it comes to subtraction, the one thing you do need to be careful of is that you distribute the negative because you have a binomial following that negative sign. So what we really have here is negative 3 plus 5i minus 7 plus 2i. Then we can combine like terms. The real part is going to give us negative 10, and the imaginary part will give us plus 7i. On this next problem, we can multiply, and since there are binomials in each parentheses, we can use the FOIL process. So here we go, F, O, I, and L. The F part of FOIL is negative 3 times 7, which is negative 21. O for outer stands for negative 3 times negative 2i, which is positive 6i. I for inner is positive 5i times 7, which is plus 35i. And the L part of FOIL, positive 5i times negative 2i, gives us negative 10i squared. But we're never allowed to leave I squared in that form. That needs to be treated as a negative 1. So what we really have there on the end is negative 10 times negative 1, which is positive 10. When we combine the real parts together, negative 21 plus 10, we get negative 11. And adding the imaginary parts together, we get plus 41i. Notice how we're tempted to write that as 41i minus 11, but the real part comes first and the imaginary part comes second. The conjugate of a plus bi is a minus bi. So what we're going to do here in this problem when we're asked to multiply by the conjugate is multiply negative 4 plus 7i times negative 4 minus 7i, changing the sign in the middle of the parentheses. Notice we have not changed the sign on the negative 4. Now, when we go to do our FOIL procedure, it turns out that the O and the I terms are going to cancel each other out by design. And so when we're multiplying conjugates, we only have to focus on the F and the L. The product of A plus BI times A minus BI is just going to end up becoming A squared plus B squared. So for us, negative 4 times negative 4 is going to be positive 16. We're going to have minus 49i squared, which is a plus 49, and those two are going to add up to give us 65. When we are dividing with complex numbers, technically this I is a square root of a negative 1. And we know we're not allowed to have radicals in the denominator. So what we do is we multiply both numerator and denominator by the conjugate of the denominator. And by design, this will get rid of that I. Up in the numerator, we will do the full foiling process, and down in the denominator, by design, all we have to do is multiply the first and the last part of our FOIL together. So, let's start with our numerator. We're going to have negative 21 minus 6i plus 35i plus 10i squared. And we know that that 10i squared will be a 10 times negative 1 and really become a negative 10. And down below, 7 times 7 is 49. We will then have minus 4i squared, but that's negative 4 times negative 1, which makes that a plus 4.